Hello and welcome back to Calculus 1 for one last time. Yeah, I know, right? So we have the final exam review and then dinner. That's what it is. So exam is 2 hours. It's in this room. Practice the exams you took before. Don't forget the project and the box and the stuff. And make sure that you are you just sleep the night before and don't study all day because you'll come here brain dead. Right, your brain will be tired. So just some light reading, like stretching, brain stretching. That's it. Yeah, because that's what happens, right? If you see Olympic runners about to run a marathon, it's not going to run for 6 hours and then go and run a marathon because at that point, right, tired. So what they do is they stretch and they speed walk and just get your blood flowing. So for you that translates into please don't do 17 problems. Just make sure you are okay with formulas. You don't have that many, it's Calc 1, but still. Concepts. Word problems, we have to have one on related rates, one on optimization. There might be a third one, and the third one is either mean value theorem or it's differentials or something like that. The rest is just calculations. We're not going to do the long limit proof and the long Riemann integral stuff. Newton method is too long also with annoying calculations. You should be programming computer to do that. So there are these few things that we are going to skip, but for the most part, what you see on your exams, practice all of that stuff. It covers everything. And you have the list of 7 or 8 learning outcomes for the course in the syllabus on page 2, which outline exactly which concepts and problems are part of this final assessment. So the goal for today is to just go through all of the problems and questions that you have. And we know that calculus consists of limits, derivatives, and integrals. And then derivatives have their ways, right, to be computed. And then application for that. And then finally, Chapter 5, integration. And we only did basics because you will have another 4 chapters on integration when you switch to Calc 2, if you switch to Calc 2. So let's take a look at any specific problems you might have, whether it's tangent line with implicit differentiation, or product rule, or logarithmic differentiation, or use substitution we did last time. So whatever you guys have, bring forth the question.
There was one that confused me. It was, I think it was on the quiz, or it might have been on the test, but it was the use substitution, right? And then it, hold on, let me think of what the quiz was.
Do you have it written down somewhere? The picture of it?
No, but I remember it was.
It came to you in a dream.
Root. Yeah, that too. But it was a root, and then it was raised to like the 5th power, I think it was. And anyway, what confused me about it was that you have the one function that's u, and then you have the other one that's du. The du had +5 or something like that, whereas the I know that was 2x plus 5, and it should have,
Just been 2x or something like that.
yeah. So it's something
That sounds like a probably bad choice of you or something, but
okay.
could be.
So you're not going to trick us like that. You're doing something like that.
Well, good to know you have the best opinion. Now, if I see the problem, I mean, that will be, if you could find it. Just look for it and we're here. No rush. Yes?
On page 396, it's the U sub questions. But definite intervals.
Okay, so what does it say?
Number 48.
Okay, so integral of
2x over x squared plus 1. That's in parentheses, raised to the second power. No, just the power. And 0 to 2.
Excellent. So this is going to be a U substitution problem, and it's going to be also definite integral. So in this case, when we switch to U, we have to switch the limits to U as well. I start by looking for what we call function derivative pair. And I see that if I keep the U as x squared plus 1, then du is 2x dx. Now I have 2x dx, which is great. So I have integral of du over u squared. And now I have to transform these limits. Let's go green. So I will use my u equals x squared plus 1 equation. And for the bottom, right, for the lower limit u1, I have 0 squared plus 1, which turns out to be 1. For u2, I have 2 squared plus 1, which works out to be 5. So now, I am integrating from 1 to 5, u to the negative 2 du. Now, I've seen a lot of issues, not a lot of issues. At least 5, 6 of you guys did not do well on integration when there are negative exponents. It doesn't matter whether you have a positive or negative exponent. You are adding 1. So, it's u to the negative 1 divided by negative 1, computed from 1 to 5. So this is negative 1 over u from 1 to 5, which is negative 1/5 plus 1 over 1. So 4/5. Yes.
Did you say that we had to put u back to what it was?
If you bring x back, then you have to use 0 and 2 as limits. So your 0 and 2 belong to x. If you transform your limits from x to u, you have the function in terms of u and limits in terms of u. So you don't have to go back to x when you have a definite integral. When you have indefinite integral, so no limits, then you must. I must. Any other questions?
The only exception for that is when it's -1, right? That you have to integrate because
Yes, oh yeah, that was a massacre on the exam as well. The ln. Yeah, I'll write it in blood. Integral 1 over x dx is ln x plus c. So now integral of a over x dx is going to be a ln absolute x plus c, because this a can jump in front of the integral, and then you have the problem above is just times a. So that one did not go well.
Sorry. If you have an x plus something on the denominator, does that also go in the absolute?
Which one?
Like if you were to put like x plus, I don't know, something, that would also go in the absolute. Or no?
Yes, yes.
Okay.
So if you have a U sub problem, and you are going to have so many of these in Calc 2 in 2 sections, that you'll be sick of these ln U subs. So you have the integral of, let's say, 3 divided by x plus 4 dx. Well, you kick 3 in front, and now you just have dx over x plus 4. Now you go u equals x plus 4, du equals dx. And when you plug this in, you have the integral, 3 times the integral of du over u. That's 3 times ln absolute u. And then you bring back x. So 3 ln x plus 4 plus c. Any other questions, concerns? Yes? Oh, well, you can put it on the side. You can put that on the side, so it doesn't matter where you, right, whether it's going to be on the left, for fractions in general, right? So if you have, you can write this question as 3 dx over x plus 4. Because as a fraction, you can kick 3 out, keep 1 up there, and put dx on the side. So it's just fractions, notation. Yeah, it acts as, because it's times, right? We know from Riemann integral, which was limit, summation, f of c, or whatever, and then delta x. So that's your dx. And it was f times this is the one rectangle, and then sum many rectangles, and then infinitely many rectangles, right? So there is a multiplication in front of dx. So that's why it can go in the numerator, or it can stay on a side. Doesn't matter. Annabelle? You want? Yes. Yeah. All right, anything else? So implicit differentiation, tangent lines, linearization, word problems.
Can we go over my happy?
Sure. What's the function?
1 over 1 plus x squared.
So concavity is actually second derivative test. And as I said before, to take the derivative, you select, you push math button, and then in the value you just say differentiate. You get your y prime as negative 2x divided by x squared plus 1 everything squared. Now, since you are doing second derivative test, you have to differentiate first derivative to get the second derivative, which is you select the function, you push math button, and then you hit differentiate. So y double prime is 2 times 3x squared minus 1. Now, obviously, this button will be available to you as soon as you're done with the final, because you know, with great power comes great responsibility. So you first have to. So now we set this equal to 0. We are ignoring the denominator, and what I have to solve is 3x squared minus 1 equals to 0. 3x squared equals to 1. X squared equals to 1/3. And finally, x is equal to plus minus square root of 3 over 3. Right? Because 1 over root 3, when you rationalize, you get that. No vertical asymptotes. So my partition values are negative root 3 over 3 and positive root 3 over 3.
This is the part that I get confused about. What happens when you do the first derivative test to those values?
But those are critical points that you get from the first derivative. And these are the inflection points that you get from the second derivative. So these are inflection points. They look,
So
these
there
two
are
tests.
additional points on the graph.
Yes.
Okay.
These procedures are identical, except the first one is done on the first derivative and gives us increase decrease. The second one is done on the second derivative and gives us concavity. But the calculations are identical. If I don't put any of the primes or anything like that, I just show you the calculation, you can't tell which one is which.
Okay.
That's the thing. Test points. Negative 1, 0, and 1. If you are not sure if you should use 1, then use 2. Root 3 is about 1.7. So call that 1.8 divided by 3 is 0.8. I mean 0.6. So clearly one would work just fine. Let's use 1. I see some of you are writing with pens, so if I switch it, then it makes a smudge.
So something that's you got it right on the I get confused on when you use as points around the critical numbers that we found, or when we actually use the critical numbers.
Critical number is the point where you have min or a max. Test points are always away from them. So now we're testing this. And we just need to compute the value, and it will tell us concave up or concave down. So that's 3, 2, this is 4, divided by 8, so 1/2, larger than 0, concave up. Then we plug in 0, 2, 3 times 0 squared minus 1, 0 squared plus 1. So we have negative 2 divided by 1, which is negative 2, which is less than 0, concave down. And finally, test 1, 3 times 1 squared minus 1, divided by 1 squared plus 1, which is 3, 2, 4 over 8, which is positive 1/2, larger than 0, so another concave up. And now, answer. F of x is concave up on negative infinity to negative root 3 over 3 union root 3 over t to positive infinity. F of x is concave down on negative root 3 over 3 positive root 3 over 3. So that's the answer. Yes.
Go over the will you please go over the definition of definite integral?
Not gonna be that.
You said human sums not
Unless this is your official request.
This is a question about implicit differentiation. Number 25 on page 205. X times the cube root of y plus y
Equals?
10.
And we are supposed to do the implicit differentiation.
205.
So implicit differentiation is going to go term by term. First we have a product rule. So we have to deal with that. Copy the first, the derivative of the second. Now that's y to the 1/3. So we have 1/3 y to the negative 2/3 dy dx because we took the derivative of y plus cube root of y times the derivative of x. So now product rule is complete, plus dy dx equals to 0. All of the terms with dy dx stay on the left, everything without goes to the right. So I have 1/3 x y to the negative 2/3 plus 1, everything times dy dx is equal to cube root of y. And finally, dy dx is cube root of y divided by 1/3 x y to the negative 2/3 plus 1. Now, in general, we don't like the double fraction, so this is another one of those cosmetical changes. We multiply numerator and denominator by 3 to kill off the fraction. So what we get is 3 cube root of y divided by 1/3 cancels. So I just have x y to the negative 2/3 and then plus 3 because 3 times 1, right? 3 distributes everywhere.
That step between finally, the step between the product rule where you differentiate everything and everything is equal to cube root of y, you just factored out dy.
Yes, because this is the term that contributes the first part over here, and this is the term that contributes the 1. Yes. Where are we talking? Line 1, line 2, line 3. Oh, yes. No one caught that. Very good. I was testing you. That's a negative because you are moving that cube root to the right side. It becomes negative. Very good, very good. I was testing you and passed. It's nice. For the rest of you.
It's not a specific problem, it's just something I was thinking about when I was reviewing tomorrow is it's calculus.
Oh.
So on the first exam,
So build up this.
well, because when I was reviewing the first exam, when we were finding the limit, and then you came to 0, 0, like now you can the L'Hopital rule.
Yes.
Can I do that on the exam?
Yes.
Okay.
You can use L'Hopital rule anytime it applies. Yes.
Okay, I just wanted to
The question is if we are doing the basic chapter 2, the limits, can we use L'Hopital? If you have 0 over 0, infinity over infinity, go ahead, L'Hopital it.
So we can get 0 as the answer.
Yes.
We go over FTC.
Okay.
We do number 9 on
Number 9. So this is. Oh, this is a different book.
Yeah.
Okay, it's fine. So we have G of S. I'm just gonna write it real quick and then from 5 to S T minus 1. No. T minus T squared. Everything raised to the 8th power dt. Good. Thank you. So they want to find the derivative in respect to S. This S is a very bad variable because the 5 and now looks like an S, and so these S's now are becoming X's. No coughing. So the derivative of the integral, I don't need the difference. 5 to x t minus t squared 8 dt. And the answer is x minus x squared raised to the 8. Good. Next question. Yeah, it just changes variables. You did not learn the part 2 fundamental general calculus? The one that says that the derivative of a to x of f of t dt is equal just to f of x?
What? Oh, is that the thing that they were talking about, the dummy variable? Oh my god.
Fundamental theorem of calculus, part 2.
That's absurd.
Next question.
No. Now I have a question about
Oh, now you have a question about question, sure.
Yeah, when do you know that you can just change the variables like that?
Because the integral and derivative cancel. They're opposite of each other. So you are only left with this. But then, because there is a variable x here, that one gets plugged in there, it becomes f of x. We can do a simple function. So d dx from, let's say, 3 to x of t plus 6 to the 4th dt. So you use u sub t plus 6 du equals dt, and you have d dx integral of u to the 4 plus c. U to the 4 du d dx, and now you are integrating. That's going to be u to the 5 over 5 plus c, and now we bring back t plus 6. So the differentiation is t plus 6 to the 5th power divided by 5 so when I take the I forgot to put that it's computed from 3 to x. So every time you have to say 3 to x. 3 to x. So now, when I plug in values for x, you get okay. So the derivative, let's do it this way. Use already derivative is written, so now just take the derivative. No, I have to write it out one more time because we are plugging in. So d dx, and it's x plus 6 to the 5th divided by 5 minus, well, I can say plus c, and then minus, when I plug in a 3, that's going to be 3 plus 6 to the 5th power divided by 5 and we can compute that. Well, there's a minus c over here that will cancel. So when you differentiate this, I hope you see that all of the terms except the first one go to 0. Because they're all constant terms. So the only one we are taking the derivative of is the basic one. So that's going to be 1/5 times 5 x plus 6 to the 4, which is x plus 6 to the 4. And that's where we started, t plus 6 to the 4, and now we have x plus 6. So what you said, the dummy variable, yeah. But we see that we can actually crank the full calculation. So what I did at first, I didn't calculate. I just wrote out the answer because I know the pattern. Right? The pattern is going to be there the more you practice. Happy?
So that only works if you have if you see the function with two different variables in it. Like on one side it says d over dx, and on the other side it says dt, so you can, like, as soon as you see that, you know that it's just.
Yes.
Oh my god.
Yes. Great. Any other questions?
What chapter sections from chapter 5 and now? It's more like 5.
Yeah, there are 5 of them. So, it's not that much, not that many. First one is annoying to calculate. The second one is definite integrals, definitely going to have that. Third one is the fundamental theorem calculus. It's a single line on your learning outcome, so it has to be there. Number 4, not so much. Those are the special formulas. And then definitely number 5. So you are definitely to see 2, 3, 5, and then maybe see 1 or 2, maybe. Any other questions?
The definition of a limit. What's non-indefinite?
We talked about it.
I know. I don't know if I had this. You said limit, so.
Yeah. And it's, I mean, limit definition to yes, one delta for limit. And then Newton's method within cover 4.8, whatever.
You have to know all the inverse trigonometry. Stuff.
Oh, that was. That's the easiest one.
That's the one that pops up. Anything else?
The final is due for another final. The project is due.
The day of the final.
Can we hand it in after the final or?
Class is over when you leave the final. There's no more class. Course is over. You walking out through that door means you're not going to miss.
It's just a regular piece of paper.
What happened?
It's just one piece of paper.
For the box?
Yeah.
Regular size, type square, and then. So your job is to see how much you have to cut out of those corners, so when you bend, you can take together a box. So you're cutting those little squares, but how big is the square? That's the question. How much do you cut to maximize the volume? Anything else? I guess that's it?
No.
No? Okay. No.
I don't understand. Okay, well then you're gonna
How about that?
Then why isn't it on the test? Oh my god, what?
How about that with another page?
Oh my god.
Going to another page.
Siri, can we go over that? Because I have
200 pages in a row.
I have no idea
Yeah, 10 minutes.
how to do that.
Where are you? The rebels. Ah,
Thank you.
you're welcome.
Those who help the most.
I know exactly how to annoy, huh?
I have that's it's just it didn't settle into my brain.
Here's another substitution problem. And we are supposed to find a function derivative pair. But clearly E doesn't play a role because there is no other E. So it's the game of 1 over x and 1 over x squared. So u 1 over x du negative 1 over x squared dx. I don't have this negative, so I'm going to put the negative in. Now, in addition to this, it's a definite integral, so I also have to swap. u1 is 1 over 1, which is 1, and u2 is 1 over 2, which is a half. So now, I have negative integral 1 to 1 half e to the u du, because this stuff is du. And then you have e to the 1 over x, which is e to the u. So now we see also the issue here that the larger number is on the lower limit. Luckily, 5.4 teaches us that if we are to swap the 1 half and 1, then you pick up a minus which would cancel this minus. Now I switch the entire integral to u, so I can just solve the problem in terms of u because I changed the limits to u as well. If you're not changing the limits, then you will solve the integral in u, go back to x, and then use your regular x limits to solve this. And the next problem, e to the fourth of dx over x square root of ln x. Amazing. Think about this for a few seconds. Yeah, that's, if you want to learn calculus to the book, this is the one. For 15 bucks. Well, this one only calc 1 and 2. You have to be careful because it says called a single variable. Get the one that doesn't have this title. Because you have single variable, multi-variables calc 3 only, and then there's one that has no subtitle, just says calculus. That's the 1, 2, and 3. 15 bucks, 16 bucks, 7th edition. All right, so what is my function derivative pair over here? Excellent. So u is ln x. And what's du?
1 over x.
1 over x. 1 over x. dx.
Yeah, oh.
It's not there for decoration. So now I have 1 over dx over x, right? That's you can put this dx over here on top, and then they look the same, right? So now integral of du over square root of u. Oh, I didn't change my limits. So u1 is ln of e, which is 1. u2 is ln e to the fourth. Kick that fourth in front of ln e, and the whole thing is 4. So now write this as 1 to 4 of u to the negative 1/2 du. Now we add 1. So that's u to a half divided by a half, calculated from 1 to 4. So now what is this? This is 2 root u calculated from 1 to 4, 2 times root 4 minus root 1, which is 2.
How did these cancel?
ln of e is 1, right?
So we changed x to
Yes. Because I use, this is the x limit, x1 limit. So I take that and I plug into x. So ln of e, I get u. And this is u now because it's u, right? So your integral is either entirely in x, including the limits, or entirely in u, including the limits. You cannot write here du over root u and u is e's. Because these are x, right? You changed, not really for this class, but I'll still say it. You transform the space, right? When you have your x as a unit of measure, right? You are on the xy plane. But then when you change your x's into u's, it's no longer x realm. Now it's a u realm. And if you use the x limits in the u integral, it's not going to go well because the appropriate ones are 1 and 4. Now, what you can do, which is dangerous, you can ignore the limits, solve the integral, get this, then plug back your ln x into this, and then put your e's.
Because I thought that's what we.
But that's more. That's what we did for all of those that are plus c, yes. Because your integral is posed with x values. Your answer must be geared in x values. But now we are transforming the space into u, and we have limits, so the answer is a number. You have to get the same value too, whether you go back to x over here and use these, right? Because it works out to be the same. Except I don't like that for 2 reasons. Well, I said dangerous. Reason 1 is the stress levels on exams are high, and if you are a person who says, I'll deal with the limits later, let me go through the integration and then bring it back to u, number of students actually don't put the limits back in the problem at all and just leave it as the completely unfinished problem. You went back to x, but your answer is 2, right? It's not a function of x. So that's the top reason why I don't like skipping over limits and then I'll do it later. The second reason why I don't like that switching is it's more work, because it's not just that you had to convert to u to solve the problem anyway. Now, when you solve the problem in u, you have to go back and have this as a 2 square root of ln x, and then you are going to plug in the e's. Right? It just
doesn't make sense.
It's more work. I mean, it's possible, of course. You're going to get the same answer, of course. But for vast majority of problems, it's more energy, more work, more, right? And then when you see these composite functions, right? Order operations kicks in, right? It's just so many, right? Right now, I'm doing just one operation. LNE is 1. Woohoo! Right? Drop the 4 in front. LNE is 1. 4 times 1 is 4. Right? It's easy. Why do I want to do all of this under the roots? Because, right, we know that the U substitution is backwards chain rule. So you are guaranteed to have function composition to compute these things if you are not doing it right away. Anything else? Hi.
How do you solve the optimization problems without being given a number?
Those are my favorite. Let's see.
So without what?
Solve the optimization problems without numbers. That means just letters.
No, it's
Use Mayan.
an example, like the one on the lab, it doesn't have it just says the perimeter is fixed, but it doesn't say what it is.
Oh, you just perimeter is fixed, so call it perimeter P.
Right, but then how do I solve?
But your answer at the end of the problem will be in terms of P. Because fixed perimeter means that number is a constant.
And then in theory, you'd be able to plug in any perimeter value.
So your answer at the end, if you're looking for x, x will be some function of P. Is that by any chance the window like this?
Yes.
Oh, that one is, yeah. Your x is going to be equal, and then it's going to go all the way up to here, and that's going to end right there. And there will be p's along the way, yeah.
So that's the answer?
Yeah.
Really?
It's going to be beautiful.
So you're not supposed.
That could have been the hardest problem of all the labs across the, yeah.
So the answer is going to have multiple variables.
P's only.
Okay.
Because everything else is given in terms of, right? If you have it like this, and this is your x, and this is your y, and this is your r, which is x over 2.
Oh, I did, yeah.
Right? So you will have area. So you have your, for perimeter, 2x plus 2y, and that already includes this line as well. And you just need the arc, which is 1/2 2 pi r, which cancels this, and that's the fixed perimeter. But r is x over 2.
Right.
So it's 2x plus 2y plus x pi over 2 equals to fixed perimeter P, and that's your constraint. That's your constraint.
And you don't have to solve for x or y?
You have to solve for y. You have to solve for y, but you still need the other equation. And the other equation is either area or whatever the other equation is. You solve this one for y equals blah, and then you plug in the objective equation. It's a standard process to solve these problems. There's no... So clearly, expressing y from this equation is going to be a living nightmare. We're going to get something really, 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 really bad on the other side, right? And then you plug that into the equation. That makes even bigger mess. Take the derivative of the mess to get another mess. Set it equal to 0 to solve the mess. And all of your answers will be in terms of P, because that's the fixed parameter. It's fun.
Is perimeter included on the it's on the outside, or is it
This part here
yeah, is that on the perimeter?
depends on how it's worded, and if there's a picture, right? So it's a line on a picture, so it should be included. Which is why I have two X's over here. Yes.
In chapter 3, we have two sections dedicated to word problems, derivatives as rate of change and related rates. What is the difference between the two?
Well, related. So rates of change, those are your velocities and things like that.
Okay.
So derivative as a rate of change, when you say you have a position s of t is equal to some function, I don't know, t squared plus cosine t, right? That's the position. And then you will take the derivative to get the velocity, which is s prime of t, which is 2t minus sine t, and that's velocity. And then acceleration is the derivative of velocity, or you can also think of it as the second derivative of position, which is 2 minus cosine t.
And if you were given the acceleration and you go back to position,
You would have to integrate. Yep. So going down are derivatives, going up are integrals. Anything else? Oh, and then the related rates. Related rates relate rates. So related rates would be, let's say you have the volume of the cylinder, so that's r squared pi times the height. Now,
differentials.
do what? No, we're doing now the related rates.
Oh, sorry.
So for cylinder, R is constant because in the cylinder, radius doesn't change as you go up and down in height. In cone it does, but not in cylinder. So in that case, r squared pi is a constant. So if I am to take the derivative of this in respect to time, and this is one of the big things that your derivative is in 311, which is the related rates. They're all in derivatives in time because you are measuring the change in time. So now I have a dv dt is equal to r squared pi dh dt. And this is, you have two rates, and they are related by this formula in the middle. This one is the rate of change of volume in time, and this one is the rate of change of height in time. And I gave the example of this as the soda can, right, sits on a desk, and then you sip on your beverage using a straw. So the liquid level would be falling, right? That's the height of the liquid. And as you are taking a sip, this is one of the problems that actually circulates for the project. Because you can Google the size of the average sip. And that's going to be your dv dt that it's leaving, right? It takes 1 second to take a sip. So you have your dv dt in volume per second. And then how fast is the volume in your soda can, right? It's one of the project questions. It's something that you actually can do. You can measure these things. Any other questions, concerns? Anything else?
Additional tips or tricks?
Yes, make sure you sleep the night before as much as possible. Leave on time so you're not stuck in traffic or rushing or getting into accident. Don't study that day extensively because you are going to be tired when you show up. So, right? It's the funniest thing when the student tells me, oh, everything in my head confused. I studied 5 hours and everything in my head is confused. I say, well, you should be lucky that you're alive at this point because you used up all of your energy, right? And now you are just brain dead. So, in all fairness, you had 4 months to learn Calc 1, right? Like the last 6 hours, if you spend that studying, then you're just showing up tired. That's it? All right. I'll see you at your respectful times this week. You're welcome. Bye.